In every company, every team, there's always that one person who's just crushing it, the star performer. But have you ever wondered, what if their success is less about actual genius and more about just getting lucky? Today, we're going to dig into a seriously powerful way to tell the difference. I mean, think about it. Your top salesperson, your best fund manager, are they a true master of the craft, or were they just in the right place at the right time? Because getting this wrong is a huge deal. It means you might be promoting the lucky ones instead of the truly skilled. But getting it right, that's the key to making way smarter, data-driven decisions. And for years, this has been the central puzzle of efficiency. How do you really, truly measure performance when there are so many different things going on at once? Look, the simple stuff, like your basic accounting ratios, they just don't cut it anymore. They're blunt instruments, you know? They can't tell the difference between an operation that is genuinely efficient and one that just got a lucky break. They just lump everything, skill, luck, good timing, all into one big cloudy number. It's not very helpful. So to get a much clearer picture, we need a better tool, something more sophisticated that can almost surgically separate that skill from the luck. And that tool, well, it's called Stochastic Frontier Analysis, or SFA for short. So here's the core idea. FSA basically calculates the maximum possible output. Think of it as the perfect score, or the frontier, that a company could possibly get with the resources it has. Then it looks at the gap between where a company actually is and that perfect score. But, and this is the brilliant part, FSA knows that gap isn't just one thing. It splits it into two pieces: genuine inefficiency, the stuff the company can actually control, and then what it calls statistical noise, which is just random shocks and pure luck. Now, SFA isn't the only game in town. Its main alternative is something called DEA, but SFA has a massive advantage. You see, DEA is what we call deterministic. It lives in this black and white world where any and every shortfall gets blamed on inefficiency. No excuses. SFA, on the other hand, is stochastic, which is just a fancy way of saying it accepts that the real world is messy. It's built from the ground up to handle the random noise and plain old luck that affects every single business. Plus, because SFA is a parametric model, it lets us run all sorts of powerful statistical tests on the results, something you just can't do with DEA. And this really nails it. As Layman put it, the world of business and finance is just full of random variables. Stuff happens. So you need a model that's built for that randomness. A stochastic model like SFA is just a much better fit for reality. It makes perfect sense. But here's where SFA goes from really useful to, well, truly powerful. It doesn't just stop at separating inefficiency from noise. It goes way deeper and actually deconstructs what underperformance even is. Right, so that gap between a firm's reality and its potential, it's not just one big mysterious blob. Think of it more like a puzzle. And SFA is the tool that lets us pull that puzzle apart, piece by piece, and see what's really going on inside. And in the advanced versions of SFA, that puzzle has 4 distinct pieces. First, you've got random noise. This is pure luck, good or bad, like a competitor's factory having a flood. Second is time-invariant heterogeneity. These are a company's built-in advantages or disadvantages, like owning a patent or being in a terrible location. It's not skill, it's just a fixed part of who they are. Third, you have persistent inefficiency. This is the bad stuff that's baked in, the chronic problems that never seem to go away, like a really dysfunctional management structure. And finally, number 4 is transient inefficiency. These are the temporary slip-ups, the one-off mistakes that can be fixed, like a single shipment being delayed. Okay, so you've got these 4 things all jumbled together in the data. How on earth do you untangle them? Well, it turns out there's this incredibly elegant 3-step process to do just that. Imagine you have a bucket filled with rocks, sand, and water, all mixed up. Step 1 is just looking at the whole messy bucket. That's your first SFA run that gets the total combined error. For step 2, you pour the bucket through a giant sieve. The water flows right through. That's your stuff that changes over time, like random noise and short-term slip-ups. What's left in the sieve? The sand and rocks, the stuff that's constant, like the company's fixed characteristics and its long-term problems. Then, for the final step, you take a giant magnet to what's left in the sieve. The magnet pulls out the rocks. That's your deep-seated, persistent inefficiency, leaving just the sand behind, which is the company's unchangeable DNA. And just like that, you've separated everything. Seriously, it's like a high-speed centrifuge for your data. You pour in this cloudy, confusing mixture of performance metrics, you hit the on switch, and it spins out 4 pure, crystal clear components. It gives you incredible clarity about what's really driving performance, or lack thereof. And I want to be clear, this isn't just some abstract theory from an old textbook. This exact method is being used right now in the real world to make huge decisions. Take a look at this. This isn't from a research paper. This is literally the title of a real-world Python script that's built to run this exact 3-step analysis across major industries. This is what SFA looks like in production. And this thing is a beast. It fully automates that entire 4-part breakdown we just walked through. But here's what makes it so powerful. It's reliability. To make absolutely sure it's finding the true answer, it doesn't just run the analysis once. It runs it 20 times, from 20 different starting points, to make sure the result isn't just a statistical fluke. It is built from the ground up to deliver clean, trustworthy intelligence that you can actually act on. So what does an analysis like this actually tell you? Well, let's look at a recent study of medical labs in the US. After they crunched all the numbers using an SFA model, they landed on this figure, 70.6%. That was the average efficiency score for the whole industry. Okay, so a score of 70.6%. What does that actually mean? It means the average lab was only operating at about 70% of its total potential. It means that with the same staff, the same equipment, the same budget, they could boost their output by nearly 30% just by fixing their own internal inefficiencies. I mean, that is a massive, tangible opportunity just sitting on the table. So, in the end, SFA gives us this powerful new way of looking at the world. It lets us move past our gut feelings and start rewarding genuine skill, while at the same time identifying and fixing the real sources of inefficiency. And that really just brings us to one final question for you. Now that you know a tool like this exists, a tool to separate skill from luck, what will you measure first?